stage 1 and there is no deviation in stage 2. So there is a deviation in stage 1 and there is no deviation in stage 2. So here now in this we are going to find out the stage 1. So the table above table given, that is of stage 1. Now if we check it, here we have value of 59, here this is value of 59 and here we have 58. So in this we are going to make it 59. We have already done this. So here we are going to get 59 value. As we will get the 59 over here, so there will be changes in case of next table, that is GB and ZB dash also. So from that we have already calculated that ZB dash is equal to 35, and now we will calculate with GB, that is gear ratio. So for calculating GB, how we can proceed with it? So we know that GB is equal to ZB dash upon ZB, which is also equal to NB upon NB dash. Now if we check for Z dash B and ZB, so from that the ZB dash value we have 35 and ZB value it is 24, so its value will be 1.46. so therefore NB upon NB dash, that will be 1.46. so this is the formula that we are going to check it. Now after getting this value 1.46, now deviation speeds we will calculate, theoretical and practical. So for that we are going to make one table, and before that we need speed chart. So I'll draw quickly a speed chart over here. So we have already drawn a speed chart, so it has 4 shafts and 7 speeds. So it is 1 2 3 4 5 6 and last one is 7. So from this, now we know this is 120 rpm, this is 170, this is 240, 340, 470 and the last one is 670. Now this is shaft 1 2 and 3, this is machine shaft, and we will draw diagram, speed chart. Now for that already we have discussed these points, so I'll just quickly draw it. So this is completed. Now we will draw with the table. Now for that we will make one table which will be having similar thing, the 6 speeds. So first one is serial number, what we have it. Second is speed, that is theoretical speed, and next column it will be of practical speeds. So N, it is practical. Now we will again go for 6 speeds. So 1 2 3 4 5 and the last one is 6. So it is 1 2 3 4 5 and 6. Now already we have theoretical speeds we have written, that is 120, 170, 240, then 340, then 470 and the last one is 670. Now there is deviation in a particular point only, and that is related to B. So we will focus on only the speeds which are related to B, and from the diagram this is B and this is A. So if we check for B, the speed deviation, it is for these two speeds. Number one is this and number two is this. So there will be deviation for 670 rpm and 470 rpm. So we have to write down the values deviation for this and this. Now other values are completely similar, so that is why we will write it 120 rpm, 170 rpm, 240 rpm, 340 rpm, and we will keep these two things blank, that is 470 and 670. For getting those two values. We will write down like this. Now for 470 rpm, now we know we are going to calculate for n dash b, that is nb divided by gear ratio, which is equal to 670 divided by 1.46, which we will take 459 rpm. So this is first value what we got it. And for the next one, for 670, now how we can proceed with it. Now for 670 rpm we need a next speed, so we haven't calculated next speed. So first we will calculate for n7. Now as we are going to deal with n6, so we need next value so that we will get the deviation. Now for n7, the formula will be 120 into 5 raised to power 6, which is equal to 945 rpm. Now for 945 rpm we are going to check, we are going to calculate for n dash b, which is equal to nb upon gb, which is equal to 945 divided by 1.46, which is equal to 647 rpm. Now as the deviation rate is the last speed, that was for 6 and 6, so that is why as the deviation for n6, so that is why we have used additional speed, that is n7. Now finally we got two answers, and those are, number first one, for 470 rpm we got 459. Now if we check it, we are getting deviation, that is lesser speed, and for 670 rpm we got 647. So for 670 we got 647. So these are two deviations what we got it. Now after getting the deviations, we will write down the values of it directly, and then we will draw it in a deviation chart. So for speed deviation, we will make one table again. Now for speed deviation, we have one formula that delta percentage is equal to n actual rpm divided minus theoretical rpm divided by theoretical rpm multiplied by 100. So from this formula we can calculate what is the maximum deviation we have it. Now for that, the next process, we are going to make one table. So in that table we will write down first n theoretical, then n actual or practical, and delta n. Now there are 6 speeds, so 1, 2, 3, 4, 5, and here we last, that is 6. So in this case, first one is 120 rpm, then 170, then 240, then 340, then 470, and the last one is 670 rpm. So in actual case we have 120, 170, then 240, then 340, then 459, and the last one, it is 647. Now in this case, if we'll check with this, here we have value deviation, that is 0, 0, 0, 0, and here it is minus 2.34, and here it is minus 3.43. Now here we are getting the final deviation values through that formula. So I'll just show you one of it. So delta percentage, how we can calculate, 459 minus 470 divided by 470 into 100. So here for 459 we are going to get minus 2.34 percentage, and similarly for delta percentage of 647 minus 670 divided by 670 into 100, which is equal to delta percentage, that is minus 3.43, that we have already written. Now we got the deviation here. Now the last point is that limits of deviation. So for limits of deviation,